I am PIrwin. Today I'm going to show you how to determine the concentration of an unknown solution using Beer's Law, Vernier LoggerPro, and a colorimeter sensor. Beer's Law states the concentration of a chemical is directly proportional to the absorbance of the solution. I will show you how to plot the absorbance versus concentration for 5 prepared standard solutions of nickel 2 sulfate using Vernier LoggerPro and a colorimeter sensor. Once the standard solutions have been plotted, we can add a best fit line and interpolate the concentration of an unknown after determining the absorbance using the colorimeter.
The graph here shows the relationship I will be discussing with our live data collected. As you can see, the absorbance is plotted against the concentration for the standard solutions, and we will be able to interpolate the concentration of the unknown as indicated on this graph. Our learning objectives in this experiment for today's video include the following. The student will use a colorimeter to measure the absorbance value of each nickel 2 sulfate standard solution, find the relationship between absorbance and concentration of a solution, and use the results of this experiment to determine the unknown concentration of another nickel 2 sulfate solution. The colorimeter has been calibrated, so we can start to collect our data for the standard solutions. I'm going to press click here at the top, and I'm going to put in the lowest concentration standard solution in the colorimeter, close the lid, and wait for the absorbance value down here in the lower left to stabilize. It's essentially considered to be stabilized when it is fluctuating just back and forth between some numbers in the thousandths place. And it appears we have reached that point, so I'm going to press keep. I'm going to enter in the concentration for the lowest standard solution, which was 0.08 moles per liter, and then I'm going to click OK. I will repeat these procedures for the remaining 4 standard solutions. I will click Stop when I am finished. I've pressed Stop because I've finished collecting for the 4 remaining standard solutions, and you're probably wondering, where are all the points on the screen? They are there, but we just cannot see them because I need to adjust the scale for the y-axis, because most of the absorbance values I noticed were above 1. So how we do that is we're going to right click on the absorbance, click on the graph options, click on axes options at the top here, and I'm going to change this to 2.0 because I noticed that none of them were above 2, and this should bring them all into view. And now voila, they're all there. So now we can analyze the data. So first I will click the linear fit button, which is this one right here. And when I click this, it's going to produce a best fit line linear regression appearing between the points. The line should pass near through the data points and the origin of the graph. All right, so in this box here, it's really kind of hard to see, so I'm going to change the options here to make it a little more legible for everybody. So I right-clicked, and on the linear fit options there, I'm going to click the appearance. I'm going to change the font size to something really big that we can see, and then click OK. And now I'm going to move this to a location so it's not obscuring the points on my graph. So we can clearly see that the slope, the y-intercept, the correlation, the closer the correlation is to 1, the better the fit is, and the root mean square error, the closer that is to 0, the better the fit is for this line, for the best fit line. So now we can interpolate the concentration of the unknown. So I'm going to take out that 5th standard solution, and now I'm going to place the unknown in the colorimeter, closing the lid, and down here in the lower left again we're going to see a live absorbance value being displayed. All right, I do not need to click collect or keep or anything. I just need to make a mental note of what this is. The value is 1.13, it looks like 2 is the middle point there. 1.132 is what I'm going to enter in. So now I'm going to go to Analyze up here at the top. I'm going to scroll down, I'm going to click Interpolate. Alright, when I come over to the graph with my mouse, you can see these data points are changing in this box. And just like the other one, I'm going to make this a little more legible. So right click, click Examine Options, and change this one to a large font as well so we can see it. Okay, I'm going to move that box, so click on it and just pull it and drag it and drop it. Alright, so I'm looking for the absorbance value here to be as close as I can get it to 1.132, because that's what the unknown was. 1.132. Alright, that looks like it's right there. The hard part here is once you get it on that number to bring your mouse straight up. Alright. To the box, and once you get up into the box you can kind of let go, all right, because it will no longer change. All right, so that is showing that the concentration for our unknown is 0.1629, etc., etc., etc. moles per liter. All right, to print a graph of the absorbance versus concentration with a regression line and interpolated unknown concentration being displayed, we're going to move over here to File. We're going to scroll down to Print Only the Graph. That way you're only getting the graph and not the table or the entire screen. All right, and you can put your name in, and most people in the comment put the title of the graph, and then click OK. And if there are multiple students in a group, you can have them print numbers of copies that they need so that every student has their own graph, and then click OK. I hope this tutorial familiarized you with how to determine the concentration of an unknown solution using Beer's Law, a best fit line, and analysis through interpolation with Vernier's LoggerPro and Colorimeter sensor.